In this video, I'll be showing you how to do what I call the windmill method. And this helps you figure out how a vector, in this case, a force vector, is related to an axis of interest when it is a function of two angles. In this case, it would first have to travel to the tangential axis, and then it would go down to the x-axis. But what is ideal is having the angle relate, or the force relate immediately to the positive x-axis. Sometimes you can just figure this out quickly. Mathematically, it's not difficult. It's just subtraction or addition. Sometimes you might throw in a 90 degrees or 180 degrees in order to do this, but it's sometimes, especially when it is in the midst of a larger, complicated problem, kind of gets cerebral and a little bit challenging to identify. Also, if you calculate this in your head, it's difficult to go back and find your error, because when you go back and work a section of the problem again, you're not checking that work, you're working the problem again. But if you have it written down on your page, you can actually visually check your work. I came up with this method when I was having a difficult time trying to figure out a vector as a function of two angles. If you Google Windmill Method, it's not going to come up anywhere. So hopefully this video can help you figure out how to work it. It's called the windmill method because when you draw the diagram, it can look like a windmill. I always start with the axis of interest. In this case, positive x horizontal and positive y vertical. Then I put in the intermediate axis. In this case, the normal and tangential axis. Tangential. Normal. It is defined as the angle theta. Theta. I go around all of the different little slices and defined the theta. So here's theta, here's theta, here is theta. When all of these are filled in, with every other one being represented, it kind of looks like a windmill. And that's where I get the name. After we've gone through and defined all of the thetas around the axes, I would go in and put the base of all of the vectors and axes at the same location, go in and define that force vector. This force vector is defined to the tangent axis using feet. With these overlaid on top of each other, it's a little bit easier to see now that it is a positive theta and a negative phi, which gets us what we can call gamma here. That relates the force vector to the positive x-axis. So mathematically, gamma is going to be theta minus phi. And you may have quickly seen that when you first looked at this problem and you're able to figure it out quickly. But if you're not able to do it quickly, or you have these vectors and axes in different quadrants, the angles are given in much more complicated orientations, this is a way that you can go through and visually identify what you're doing.